Look up at the night sky and you see stars, planets, and vast clouds of glowing gas. But the most foundational truth of our universe is that everything we can see, every atom and every star and every human being, makes up only 5% of the cosmos. The rest is a mystery that has baffled scientists for nearly a century. We call it dark matter, and today we are diving into what it is, why we know it's there, and the leading theories that might finally explain it. Hi everyone, Liam here. If you're fascinated by the engineering of the future, subscribe and follow for more science, natural, and cosmic content. To understand dark matter, we have to look at how galaxies move. Astronomer Vera Rubin observed that stars at the edges of galaxies were spinning just as fast as stars near the center. According to the laws of physics, those outer stars should have been flung off into space, like a rider falling off a merry-go-round that's spinning too fast. There simply wasn't enough visible matter to provide the gravity needed to hold them in. Rubin concluded that there must be a massive amount of invisible matter providing that extra gravitational glue. This led to a startling realization in foundational science. Galaxies are like flies caught in a spider web of invisible material. As NASA's Science Mission Directorate puts it, dark matter is like a cosmic scaffolding. It doesn't emit, absorb, or reflect light. We can't see it with even our most powerful telescopes, but we can see its influence. It bends the light from distant stars, a process called gravitational lensing, effectively acting as a giant magnifying glass in deep space. So, what exactly is it? For years, the leading candidate was a theoretical particle called AWIMP, or Weakly Interacting Massive Particle. The idea was that these particles are all around us, passing through our bodies and the Earth itself without leaving a trace. However, despite decades of engineering incredibly sensitive detectors deep underground, we haven't found a single one. This silence has led many researchers to look toward a different candidate in 2026, the Axion. Ixions are ultralight particles that were originally proposed to solve a problem in nuclear physics. They exist, they would be much lighter than an electron, but produced in such vast quantities that they could account for all the dark matter in the universe. In a recent 2026 update from the ADMX research team, scientists noted the Axion is now one of the most compelling explanations for dark matter because it ties together physics of the very small with the physics of the entire universe. But what if dark matter isn't a particle at all? A third, more controversial theory is called MOND, or Modified Newtonian Dynamics. This theory suggests that our foundational understanding of gravity is simply wrong when it comes to the vast distances of space. Proponents of MOND argue that gravity acts differently on a galactic scale than it does on Earth. As physicist Mordechai Milgram, founder of the theory, has said, we may not need to find a new particle if we simply find a new law of nature. Despite these competing ideas, the evidence for a physical substance remains strong. In early 2026, data from the Vera C. Rubin Observatory provided the most detailed maps of dark matter to date, showing how it clumps together in a cosmic web that spans the entire universe. These observations reinforce the idea that dark matter was the primary architect of the cosmos, pulling ordinary matter together to form the very first stars and galaxies. Solving the mystery of dark matter is the ultimate goal for the engineering of the future. Whether it is an invisible particle like the Axion or a fundamental shift in our understanding of gravity, the answer will rewrite the foundation of physics. We are currently living in a golden age of discovery, where the invisible is slowly being brought into the light. Until then, we continue to look up, knowing that the vast majority of our universe is still waiting to be understood.